Am I recording? Yeah. Of course I am. Good. Okay. So here we're going to have a few more extra examples. I want you to try them using the methods that we had before. Remember, always plug your value in first. Then, if it doesn't work, try your math magic. Check your answer with a calculator and a table of values and make sure you've got the right thing. Okay, let's start off with number 5. If I plug in 1, notice what I'm going to get. 1 to the 4th minus 1, which is 0, and then 1 to the 3rd minus 1, which is also 0. So the 0 in the top isn't a problem. It's the 0 in the denominator that's causing a snafu. So we're going to have to do some math magic. All right, so limit as t approaches 1. The first thing I'm going to do is I'm going to factor this. The numerator, believe it or not, the numerator is a difference of squares. See how that 4 is an even power? Anytime you have a variable to an even power, you can take the square root of it, a perfect square root. So t to the 4 minus 1 can be factored into t squared plus 1 and t squared minus 1, which can be factored further, but we'll do that in a second. Let's factor the denominator. The denominator is, do you remember what it is? Talked about it earlier. Yes, a difference of cubes. So this is like saying t to the 3rd power minus 1 to the 3rd power. So I'm going to factor that into t minus 1, t squared plus t plus 1. Notice, nothing can cancel right now, but I do have more factoring to do. So let's see if I can factor some more. The denominator here I can't factor. The numerator, specifically the difference of squares right here in t squared minus 1, that can be factored. So sum of squares, not factorable. Difference of squares, totes factorable. Da da da, look what happens. T minus 1 and t minus 1, poof, disappear, go bye-bye. And then I'm going to have the limit as t approaches 1 of what I've got left in the top. T squared plus 1 times t plus 1 all over t squared plus t plus 1. Now that I've gotten something to cancel, I'm going to plug my limit value back in. So I'm going to have 1 squared plus 1, that's 2, times 1 plus 1, which is 2 again. So this is like saying 2 times 2. And then 1 squared plus 1 will give me 3. And my answer ends up being 4/3. Double check it with a table of values to make sure that it works. Remember what that means. The table of values, you're looking at values close to 1. So what are values that are close to 1? Well, smaller than 1 would be 0.9, 0.99, 0.999. You get the picture, right? Bigger than 1 are going to be 1.1, 1.01, 1.01, 001, da, 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 da. Okay. I think it's 4/3. If it's not, I will just check it later. I need a clone. I need somebody in here with me to check it on a calculator while I'm recording. That's not going to happen. This 4/3 looks really good on my face though, so hopefully it's right. Okay, let's look at the next one. Let's take a look at this next problem. Plug in the h equals 0 first. So I'm going to have 3 plus 0, which gives me 3. This is going to be 1/3 minus 1/3. That gives me 0. And then h equals 0. I get 0 over 0 again. All right. So now I want to solve that. I'm going to simplify it. Do some math smoke and mirrors. The first thing I'm going to do is I'm going to write it as fractions. So I'm going to write it without the negative exponents. So instead of having 3 plus h to the negative 1, I'm going to write 1 over 3 plus h. Then I'm going to write it as minus 1/3 and put that over h. Next. Here in the numerator, I've got an LCD of 3 and 3 plus h. So I can build up the fraction, or what I can do is multiply the top and the bottom of this fraction, and I mean the whole fraction, by the LCD of the top. Watch what happens. Okay, when I multiply this here, keep in mind that this is a binomial. I need to multiply it by both pieces. When I multiply this 3 times 1 over 3 plus h, notice what will happen. I'm going to write it out for the first one, maybe the second one. But the idea is that you'll kind of see what's happening. So here I'm multiplying it out by the first one on the top. Notice what's going to happen. Yeah, my 3 plus h's are going to cancel. Sweet. Okay, next one. I've got 1 over 3. I'm going to multiply that by this. So I'm going to rewrite that. I'll write the product out. And then in the denominator, I just have h times all of this. So I'm just going to write it as 3h times 3 plus h. Now, nothing supremely magical is happening yet, but I do have to do some simplification. Keep in mind that I've got some things that are canceling. This cancels. And what else happens? Yeah, this cancels. And this is the magic of multiplying out by the LCD. In the numerator, I've canceled all the denominators. So all these pesky denominators here, I've gotten rid of. And the only thing I have left is here I have left 3. And then minus my 3 plus h. Okay. Now, let's see what we've got. Oh, yay! So if I distribute this negative sign out, notice what will happen. I end up with 3 minus 3 and a negative h. Well, 3 minus 3 is 0. And I end up with negative h for the numerator. Oh, whoops, sorry. The bottom, I forgot these pieces. I got too excited. Okay, so for the numerator, it's simplified to negative h. In the denominator, I've got that 3h times 3 plus h. However, notice what happens. Pow, pow, cancel. So I'm just left with the limit as h approaches 0 of negative 1 over 3 times 3 plus h. Well, that's exciting because now I can plug in my h equals 0 again. So h equals 0, plug that in, and I'm going to get 3 plus 0, which is 3, 3 times 3, which is 9, and I end up getting an answer here of negative 1/9 for my limit. Again, if you don't believe me, which, why should you? You haven't met me. I could totally be lying. Check it with a table of values. Use values that are very, very close to 0 and see if you can get something that's close to negative 1/9. Let's do some more. Next set of problems. Again, give them a shot first. Hit pause, work them out, see if your answers match mine. You ready to check them? Okie dokie. First thing, plug it in, make sure that it works. I'm going to write here, there we go. All right, so the limit as t approaches 6. By the way, even though I just said it, I forgot to do it. Make sure that you plug it in. Take that 6 and you end up with 0 over 0. The 0 in the denominator is a problem, so we need to adjust it. What I have is this fraction within a fraction here, and it's very similar to the last problem that we did. What we're going to do is multiply by the LCD, the lowest common denominator. Here, and I'm ignoring this denominator. Here, I have a denominator of t. Here, I have a denominator of 6. So what I'm going to do is I'm going to multiply the top and the bottom by 6t. When I do that, keep in mind this is a binomial. I'm going to multiply this here and here. When I multiply this out by the first one, the t's are going to cancel. And I'm just going to end up with 6 times the numerator. So this is just going to give me 6 times 1. When I multiply it by the second one, the 6's cancel and it's going to be t times the numerator. So this is going to end up as 6 minus t. In the denominator, I'm going to end up with 6t times the t minus 6. Notice once we've simplified it, after multiplying what we have, it looks like we have something we can cancel, but be cautious. Keep in mind, if I have something like 6 minus t over t minus 6, they do cancel each other. Oh, sorry, I wrote that over the words. They do cancel each other, but they cancel each other with a -1. So let me just rewrite that over here. Sorry, my bad. So if it was addition, if it was 6 plus t plus 6, it would cancel with 1, no problem. But this is subtraction. They're not quite the same. They're opposites of each other. So this thing is going to cancel, but it's going to leave behind a -1. So I'm left with this remaining fraction of -1 over 6t, and then I can plug the 6 in. If I plug the 6 in, I'm going to end up with -1 divided by 36. So I'm going to have -1 over 36. Again, plug that into your calculator. Use values that are very, very, very close to 6. Let's try the next one. Okay, so I'm going to have my calculator out for it. I want to plug in the 2 first. So I've got 2 squared, okay, minus 4 times 2 plus 4. I get 0 in the numerator. Surprise, surprise. For the denominator, I've got 2 to the 4 minus 3 times 2 squared minus 4. Also 0. You guys seeing the pattern here? Okay, remember, always plug it in first though, because if it works the first time, you may not have to do all this. But it didn't work. We have to solve it. So, I'm going to factor. I don't have an LCD to add or anything like that. Easiest way to get rid of this or to simplify this is going to be to factor. Numerator, let's look at how that factors. What factors of 4? Add to give me -4. That's going to be -2 and -2. So this factors into x minus 2 and x minus 2. I normally would write that as, x minus 2 squared, but I'm going to cancel some things out. The next one. Notice this. I don't know if you remember this from your pre-calc classes, but this is what we would call quadratic in form. Just imagine if you had this x to the 4 minus 3x squared minus 4, imagine instead if you had this equation. You had u squared minus 3u minus 4. Can you factor that one? Well, yeah, that's easier to factor. What factors of 4? Subtract to give me negative 3. So I'm going to have u minus 4, u plus 1. So how we know that it works is that, see how this power of 4, what's half of 4? It's 2. This is called quadratic in form because it has 3 terms. And the power on the first variable is twice the power of the second variable. So that's called quadratic in form. If you don't remember it, you can Google it. I bet at least 30,000 videos on how to factor quadratic in forms will come up. Anyways, when we do this, this is like assuming that u is equal to, in this case, x squared. So that means that this guy is going to factor into, instead of u minus 4, it's going to factor into u squared minus 4. And instead of u plus 4, it's going to factor into x squared plus 4. Neat trick, huh? All right. Nothing cancels except I can see I've got some canceling left in my future. I can do a little bit more factoring, so I'm going to do that. The top I can't factor anymore. The bottom I can factor. Just that difference of squares, though. That difference of squares, sorry for the squeaking, is going to factor into we're going to put that marker up for a little bit. Let it think about what it's done. It's too loud. X squared plus 4 doesn't cancel, so we leave that as it is. Bam, 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 bam. The x minus 2's do cancel, which is wonderful. Oh, that's the squeaky one. Oh, this also seems to be squeaky. And then I'm left with this. All right, time to plug and chug now that I've gotten something to cancel. In the numerator, I've got 2 minus 2. That's going to give me 0. In the denominator, I'm going to have 2 plus 2, which is 4. And then 2 squared, which is 4, plus 4 gives me 8. So I'm going to end up with 0 divided by 32, which is 0. So this limit ends up being 0. Isn't that interesting? First, we start off with 0 over 0, and we get something like negative 1 over 36. Then we get 0 over 0, and we end up with an actual value of 0. Fascinating, huh?